Okay, we're going to look at two worked examples for linear motion. The first one is in front of us now. September 1st, 2012, the satellite Voyager 1 was 18.2 times 10 to the 9th kilometers from Earth. A radio signal travels at 3 times 10 to the 8th meters per second. How long does it take for NASA to get a radio message from Earth to Voyager 1? So again, I told you I want you to use the guess method, so let's list the givens. Sometimes it's easier to highlight them in the problem and then go back and list them, so let's give that a try. So we have September 1st, 2012. Now it's information, probably not going to be too important. We have Voyager 1 information, but again, not too important. We have 18.2 times 10 to the 9th kilometers. That's probably going to be important. We have it travels at 3 times 10 to the 8th meters per second, which happens to be the speed of light. And again, we have the reference to Voyager 1. And then we have the question, what we're hunting for, how long does it take? Okay, so we've got the information highlighted in the problem. Let's write that down to the side of the problem. Okay, the information has been written down, and taking a quick look at the units, we can see there's going to be a difficulty. We've got this in kilometers and this in meters per second. And we're hunting for time. Go ahead and write our equation over here. In this case, it might be advantageous to rearrange the equation first. So we've got the unknown in the denominator, and the first thing we do when we have an unknown in the denominator is get it out of the denominator. So we do that by multiplying through by t. And then we have TV equals distance, and of course we get rid of the v on one side. So we have our rearranged equation. Now we just have to substitute in and solve. Okay, the answer is in seconds, but it's very unwieldy in seconds, so we're going to go ahead and convert it to minutes. So I'm going to do that over here. And even at minutes, it's a very large number, so going ahead and converting it to an hour, we would have... So there you have your answer in seconds, minutes, and hours. Hours, in this case, would probably be the preferred unit, because it's more easily understood. Now we have a slightly more interesting problem. Pulled Ellie back in, so a blue heron sees Ellie and starts to fly away at 20 miles per hour. It takes Ellie 45 seconds to start chasing the heron. How fast would Ellie have to run to catch the blue heron in 15 minutes? So we have a lot of information here. Again, I'm going to go in and highlight the information in the problem first, and then we're going to go ahead and list it out. We've got the blue heron flying at 20 miles per hour. You've got to be careful to put in that 20 miles an hour with the blue heron and not with Ellie. And then it takes Ellie 45 seconds to start chasing the heron. So that's an Ellie thing. And then we want to know how fast would Ellie have to run to catch the heron in 15 minutes. So we've got two different people involved here, the blue heron and Ellie, well, a bird and a dog. And we have to be sure we get that information correctly assigned to the right animal. So I'm going to go ahead and have a velocity, and the velocity is for the blue heron, BH, is equal to 20 miles per hour. Then we've got a time for Ellie, and it's 15 seconds. And that's actually a time delay, so I'm going to kind of like add that information off to the side because I don't have a good way of shortcutting it and getting a shortening. So not 15, I'm sorry, 45 seconds. And then what we're hunting for how fast will Ellie run. And we have another time. We have the time for Ellie's run equal to 15 minutes. So we've got two Ellie times, and we only have one velocity for the blue heron, so we've got to work this out a little bit. The other thing we've got are some unit problems. This is in miles per hour, this is in seconds, and this is in minutes. So the first thing, before we figure out how to tackle the problem, how to set it up, let's get rid of the unit problems first by converting everything to meters our seconds, our meters per second. Okay, so let's go ahead and do that. Okay, well, I've rewritten the information so the units all agree. So we have the velocity of the blue heron is 8.94 meters per second. The time it takes for Ellie to catch it, she has 900 seconds after the blue heron starts to catch it. And then it takes Ellie 45 seconds to actually start going. So we've got to do two different problems. We're hunting for the distance. First thing we're going to do is find out how far can the blue heron fly in 900 seconds. So we're going to go ahead and do that problem first. So we're going to get the distance that the heron can fly. Okay, so we've worked out this fairly straightforward problem. The distance the heron can fly in 900 seconds is 8,046 meters. So now we know how far Ellie has to travel in order to catch the heron. So in 15 minutes, if she wants to catch that heron, she's going to have to travel 8,046 meters. But Ellie doesn't really have 900 seconds. She only has 900 seconds minus 45 seconds because that's her reaction time. So let's rewrite some stuff here. So what I've done is I've written down the time it takes for Ellie to run, the time she has to actually run and cover this distance, is equal to the time Ellie has to catch the heron, the 900 seconds, minus the time it takes for Ellie to start. So we've got 900 minus 45. In other words, Ellie's going to actually be running for 855 seconds. So now we know the time that Ellie's going to be running, so we have that time. We know the distance she's going to cover, because that's how far the heron's going to fly. So now it's pretty easy to figure out the velocity. So let's go ahead and do that. And that velocity for Ellie would end up being 9.41 meters per second. And I've clocked Ellie at about 11 or 12 meters per second, so she'd be able to do it. Whether she'd be able to do it for that long a time period, I'm not sure. She's never caught a blue heron, and let's hope it stays that way. Okay, that's the end of my examples. Thank you very much.